time. Let's get started. Can everyone hear me okay at the back? Good. So welcome. My name is Amol. I'm Director of Vulnerability Labs at Qualys. And in the next hour or so, I want to share some of my thoughts on vulnerabilities, on remediation, on how to prioritize them, and so on and so forth. But before we start, so last night when I flew in here, I checked into the hotel. I said, okay, this is a little bit of a time off because I usually work off a cave, being an engineer, don't get to travel much. But I said, okay, let me watch some TV. I was watching some old episodes of CSI, and I saw there that there is this team that looks at cases every day. You know, they look at bad things happening, like thefts, murders, all these bad things happening every day. And still at the end of the day, when they go back home and when their wife or husband, whoever asks them, hey honey, how was your day? They're like, yeah, it was okay, it was fine. But what really goes on in their mind is all the things that they have really seen on a day-to-day basis. And I think each one of you also would have related to that sort of situation, not at that level, but up to a certain way. So when my wife today, she called me early in the morning, she said, hey, how is your day going? What came through my mind? I was like, today there is a Cisco WebEx vulnerability, literally today, where the description says that an attacker can join customer WebEx calls, can see what are the calls that are scheduled, and basically join your calls. So that was today. Yesterday, let me think. I said, okay, yesterday Microsoft fixed 3 zero-day vulnerabilities. So basically, where if you use Edge or Internet Explorer, you go to a bad website, you get compromised. And these are not theoretical vulnerabilities, these are ODAs. So they were already used by attackers. Day before yesterday, there was a vulnerability in the malware protection engine where an attacker can just send you an email. If you are running that particular Windows malware protection engine, you could be compromised remotely. I would say, this is like a pattern. I can just even remember it. What are the things happening every day? Let me try harder. What about the day before? There was an Intel vulnerability in the firmware. I mean, how many of you use laptops that don't have an Intel chip? Where again, an attacker can remotely send some packets and remotely control your laptop. And by the way, there is no fix for that either. I was like, this is interesting. Let me try harder. I was like, okay, last week, before the Intel vulnerability, there was the shadow brokers attack. So, I mean, shadow brokers, have you guys ever I think I see a lot of heads nodding. So basically it's a attacker, it's a group of people on Twitter. No one knows who they are, but they sort of claim that they have found some NSA tools that NSA used to hack into some of the banks in the Middle East, so that, well, NSA would not want to steal any money, but to see how the transactions are going and where the money is flowing. And as a result, I mean, how am I affected? Because it had exploits for Oracle, it had exploit for Windows, it had all these exploits that they just dumped. And well, okay, to give you a little bit of a background, what I do on a day-to-day basis is I monitor all these activities, and then what my team does is we create signatures to identify these threats. So, long story short, things I don't think are getting better. About 20 years ago, in the mid to late 90s, when I was fresh off school, I had these shiny master's degree. I was working as a developer at McAfee, which was called at Network Associates at that time, as a firewall developer. So at that time I was like, okay, this is cool, firewall. At that time it was on the cutting edge of technology. I was like, okay, once we build good firewalls, we are good. I mean, once we can stop the attackers from coming in, once we protect all these services, what's there to protect now? It's all done deal now. But I mean, as you know, 20 years after Still, attacks are getting more and more complicated. Attackers are getting more and more determined. There is a lot more complicated technology that we are using that we used to use, and as a result of which there are vulnerabilities, attacks that are not just theoretical, that are happening on a day-to-day basis, and their frequency is increasing. Now, working for a security company all these years, I can sort of understand that how I have sort of learned how to cope up with this day-to-day attacks and not to get depressed. But I can only imagine people whose business is not security. So whose business is manufacturing tires, whose business is in healthcare, whose business is making burgers, or whose business is finance, which is completely not security. So all these companies, they are not immune. They also have to deal with these attacks on a day-to-day basis. So what I'm trying to share here today is, in this threat landscape where attacks are happening each and every day, where the frequency of attacks is just getting higher and higher, how do you prioritize remediation? How do you say that, okay, I would do this first and I will do this next? And the reason behind that is there is no organization that at least I have seen so far who has remediated everything. There are, most of you must have some kind of a vulnerability management program in your organization, and there is always things to do. Even if you say that, okay, as of yesterday, I had fixed or remediated everything in my organization, which is impossible, but even hypothetically speaking, you say that, okay, what about the Cisco vulnerability that came out today? Do you use Cisco WebEx? Possibly half of you would say yes. You are again exposed. So even when theoretically, if you say that, okay, I have fixed everything in my organization today, in the next hour or so, again you are unpatched, again you are exposed. So in this presentation, we'll discuss sort of a year-long study that studied exploit kits and attacks, and go over some of the prioritization techniques. So this, as I was mentioning, this is the rise of vulnerabilities that we have seen over the course of years. These are unique vulnerabilities, so these are unique CVEs. So let's say today's Cisco WebEx vulnerability counts only as one in this in this chart. You could have, let's say, hundreds and thousands of machines in your network or your laptops that do use the Cisco WebEx plugin, but it's still just one vulnerability. So this chart, it counts only the number of unique vulnerabilities, and this is public data. So as you can see, I mean, vulnerabilities from 2000, or the era that I was talking about when I was working as a firewall engineer, where the number of unique vulnerabilities were 2,000. Now it has grown to about 78,000, or there are a total about 80,000 unique vulnerabilities, and new ones being added every hour. So before we go further, I just want to make sure that we are on the same page on what is a vulnerability. So I think most of us here know what a vulnerability is. It's a flaw in the system that could provide an attacker a way to sort of bypass your security controls. Now, a vulnerability does not mean that it's being attacked right now, or you are under attack, or something bad is happening necessarily. A vulnerability just means that there is a flaw and it could be exploited. The example that I've taken here is Adobe Bulletin, which is a vulnerability in Adobe Flash. So then what happens, what is an exploit? So an exploit is basically something that turns a vulnerability, which is a weakness, into an actual way to breach a system. So the example that I just showed you earlier was Adobe Flash vulnerability, a theoretical vulnerability that yes, if your browser plugin uses Flash, and if you do visit a malicious website, the malicious website could compromise the Flash plugin inside your browser and basically take control of your machine. Now, exploit on other hand is a working exploit. It's a proof of concept. It's a piece of code that really works. It's not just a security bulletin where the vulnerability is typed out in words, but an exploit is actually something that is actually working. And there are many places, free as well as paid, on the internet where you can find these exploits. So one of the free sites that I go to is the exploit database. It's like the most common place. I think most of you must be going to check on exploits. And there are many other free as well as paid exploit frameworks that you can go to. And last but not least are the exploit kits. Now, these are really the bad actors. So basically, exploit kits are toolkits that are used for the purpose of spreading malware. So basically, they have, what malware creators have done is they have sort of automated in a SaaS, like software as a service basis, on how to spread malware. And I think what we are going to look today is how these exploit kits work and how they sort of infiltrate an organization, and what can we do to protect against these exploit kits. So this is a little bit of a busy slide, but it just and it's courtesy of Microsoft. It sort of tells you how these exploit kits and exploit actors work. So the reason I gave you the Adobe Flash example before was because it was pertaining to these exploit kits. So these days, if I'm a bad guy, if I'm a malware creator, or if I want to get my malware on your laptop, I don't have to be very technical. Actually, I don't have to be technical at all because of these services that are offered on the underground. So what I do, let's say I am a bad guy. I want to have my malware on your computer, and I don't know much about exploitation, about vulnerabilities, and so on and so forth. What I do is I create my program, which is, again, it does not do anything with vulnerabilities, attacks, or anything. It's just a keylogger. So it's just a Windows program that when you start running that program, it just start logging keys. It doesn't have the ability to infiltrate your laptop. It doesn't have your ability to look at what are the vulnerabilities. It's just a simple program. And what I do is I pay these exploit kits, or these actually SaaS-based exploit kits, and say that, hey, here is my program. Go install it on whatever machines that you find vulnerable. So again, the way that it works is, on the left-hand side is your PC, like it's a victim PC. As an attacker, I create this program, I join this exploit kit community, I sort of pay them. And when your computer visits a malicious website, or the exploit kit website, what does the exploit kit does is that it starts analyzing what browser you're using. It starts analyzing the version of your browser. It checks if your browser has any vulnerabilities that it can exploit. I mean, every browser has vulnerabilities, right? I mean, just because Chrome and IE and Firefox, most of them now do auto-update. If you look at the history of any of the browsers, like changelog, there are vulnerabilities being fixed almost every week for every browser that you use. It's just that now it's automatic in many browsers. In case of IE, you can still do it manually, but in case of Chrome and others, it's just automatic. You don't know about it. So anyway, when you visit a malicious website or this exploit kit website, they sort of scan your browser. Because your browser is connected to their website, they can tell what version it is. They can also scan what plugins are installed in your browser. So they can check if, say for example, Adobe Flash is working in your browser or not, if you have Flash enabled or not. If Flash is enabled, then they look at, okay, what version of Flash you are running. And in this way, on the right-hand side, as you can see, they sort of customize an exploit or an attack for you, for your browser version, for the exploits, for the plugins that you have installed in your browser, and for the vulnerable versions of the plugins that are in your browser. And they create that type of exploit for it, and then sort of deliver that executable that an attacker has given them. So as I said, again, if I pretend to be an attacker and I don't have much knowledge of how to infiltrate your machine, what I do is I sort of go underground, I pay these exploit kit SaaS-based vendors. This is all online. After I pay them, I give them my binary. They do all this, and then what I get again as an attacker is just sort of a login and a web page where I can log in and see which machines have my malware running. So these are some sample screenshots of some of the exploit kits. As I said, these are all web-based exploit kits. So, I mean, if you go to a forum, you may think that, oh, this is just forum or something. But when you log in, these are actually exploit kits. So Crime Pack, Angler, Phoenix, these are some of the example exploit kits where as an attacker, let's say if I have given them that, hey, this is my malware, spread this. After a few days or when I log in, I get such screens where I see that, okay, my exploit was installed on this and this particular IP, which was running this operating system, had this browser, had this plugin, and it's just like a console for me as an attacker to see, okay, now I should be getting some traffic from these IPs because, I mean, hopefully when I as an attacker have given this bad binary to them, it will call back and start giving me data. And these are just some examples of these online SaaS-based exploit kits that are available. And by no means this is a complete list. They go sort of up and down. Angler used to be one of the leaders in this business. It has sort of gone down these days. But these are just some of this is, and as you can see, they have like a lot of branding towards it. They have their own logos, so it's like a business. It's a proper business of trying to infiltrate users' machines, and they have created a good business model out of it. So how can these exploits, and this is just one example of how attack happens. So exploit kits usually attack client-side vulnerabilities. So basically vulnerabilities that could be affecting on desktop or client machines. There are other ways, obviously, where server-side vulnerabilities are affected and so on and so forth. So the question is, how can these exploits, how can these attacks, and how can this malware help us as a defender? So now I'm not that attacker anymore. Now I sort of change my hats and I'm the defender. How can it help a defender prioritize remediation? So one side I see that these number of attacks, number of vulnerabilities coming in each and every day. And on the other side, I see most or like all organizations having a lot of unpatched vulnerabilities. And the reason for that being is that people are just overwhelmed. I mean, when you start doing vulnerability scans or some sort of when you start your security program, I mean, because of the sheer volume, I mean, there are so many things that need to be remediated, so many things that need to be patched. There is, most organizations get overwhelmed by this, and I think there is a good need to prioritize on what should be remediated first, what should be remediated second, and so on and so forth. It is, in my opinion, no longer feasible to say that you should have everything patched, because that's just not possible. I mean, as I said, if you just had everything patched as of yesterday, okay, today you have a new issue. If you patched all your instances of that issue this morning, in the evening you'll have a different issue. This is a chart that shows the number of vulnerabilities that had exploit associated with it. So we started with the distinction of vulnerability and exploit, right? A vulnerability is something where a vendor says that, yes, I have a security flaw here, and that's it. There is a security bulletin, security vendors write checks, and it may pop up in your vulnerability management program as one line item saying that, hey, I'm running this and this software which has this vulnerability. If you compare that to exploits like working proof of concepts, then there are a very few number of vulnerabilities that have exploits. So this is the chart 2012 to 2016. The blue columns are the number of unique vulnerabilities. So for example, the Cisco vulnerability of today will be one of them in the blue columns, but it will not be there in the orange columns until there is a working exploit. So until someone has really figured out a way of how to really make use of that vulnerability. So this is something that, as I mentioned, we have been tracking over the past year or so on how many exploits really happen as compared to vulnerability. So I think this is a very good starting point, which means that yes, we want to patch and fix everything, but if we prioritize based on if something is really exploitable, then I think that those are the type of vulnerabilities that should be given the first priority. Any questions on this chart or what it is, or you can do this yourself. You don't have to buy any tool. I mean, if you have a tool, if some tool is helping you do this, great. But in my opinion, you can also do this yourself by tracking these exploits from some, and there are a lot of different sites that you can do that as well. So I think that is the first thing that you could do, is basically instead of trying to patch everything, first look at the attack surface and patch things that do have exploits. I tend not to distinguish between remotely exploitable vulnerabilities and local vulnerabilities and all that, because vulnerabilities are vulnerabilities, exploits are exploits. I mean, if you give a client side or local vulnerability lower privilege because an attacker cannot actively attack it, then I don't think that's right, because again, a user in your organization can simply just visit a malicious website and get compromised. So that's the reason I don't make that distinction. So again, this is a busy chart, don't try to read it, but I think the presentation would be available online. So once you download it, it has on the left hand side the vulnerabilities or CVEs for 2017 that recently had exploits. So if you have one of these CVEs in your organization, I would say patch them first, because of course there is a proof of concept, there is a working code which is exploiting those vulnerabilities. So fix those first. Second thing is prioritize vulnerabilities that are being actively attacked by threat actors. So these are pretty simple concepts, but once you put the numbers behind it, it's really very clear. So again, the blue lines are the lines that are the total number of unique vulnerabilities. The orange ones are the vulnerabilities that have exploits. And the red ones, which is again a very small part, are vulnerabilities that are really actively being exploited by malicious actors, like right now, or have been exploited by malicious actors. So to give an example, let's say maybe the Intel vulnerability from Monday or last week, which allows an attacker to take control of your laptop. It's a firmware thing. It would be in the blue box. One of the, I think it will not be in the red box, because yet we haven't, none of the IDS companies, none of the antivirus companies have seen active attacks using that. So the red box is the one which has vulnerabilities that are being used in active exploitation. So I think that is the distinction between these three charts, which is basically the blue one, which is the vulnerabilities that yes, you have to fix them eventually. The orange ones for which someone has written a proof of concept code. It could be a researcher, it could be a white hat security researcher who has written an exploit code, but someone had said that, hey, this is possible and this is the code for it. And the red ones are the vulnerabilities that are actually being attacked in the wild right now. Again, this is a pretty busy slide. When you download the presentation, you can look at, these are some of the vulnerabilities that have been targeted in this year, recently. So they are being used right now for in active exploitation. So if you have one of these, then I think it's very critical to remediate them first. Any questions so far about the three different things? Good.
How do you know that? So in other words, I know you built that list because you remember that. If we're in an organization trying to run the process continuously, how do we know when vulnerability goes from at least a week ago there was no exploit, a week later there was an exploit, a week later after that, week later back. That seems like a non-trivial thing.
Yes. It really depends on the resources that you have at your disposal. The easiest thing is to basically go and contact. You must be using some sort of a vulnerability management program, some sort of a security program, and a lot of vendors these days do provide this additional intelligence where they can tell you that that you have this vulnerability, but out of these 50,000 vulnerabilities, you have only, let's say, 5,000 have an exploit available, and even out of these 5,000, there are only 500 that are being actively exploited. If you want to do it yourself, completely by yourself, then, as I mentioned, so to find the orange vulnerabilities, I think there are a lot of free resources. So ExploitDB, for example, is an exploit database. Again, I don't have, or my organization doesn't have any tie-ups with them, but it's just a database where what they do is they try to, whenever there is an exploit out there, they try to put that exploit on their site. So if you want to do it completely yourself, you can monitor some resources like the ExploitDB, or like I think I had in some of the previous slides here given. So I think in here 2 of them are free, 2 of them are paid. So you can monitor the free ones at least, and actually I am a pretty big fan of the free sites as well, because what we have found was that the information that they have is also pretty good. So it's not that you do have to pay big bucks to get this information. You may need to have some resources on your end to maybe write a little bit of an API to integrate with their API and get that information and do that. So yeah, there are resources available to, in my opinion, pretty easily to get to the orange chart. The red ones are, I think, a little bit of a tricky ones right now, because if you want to do it by yourself, again, if you have a vendor, I would say a lot of vendors give this information, so just contact your vendor and they will be more than happy to sell it to you for a little bit of extra cost. But if you want to do this yourself, the red ones, then pretty much you have to, you would need to sort of monitor what's going on in the activity in the wild. And that is something I think would be a little tough to do it by yourself. Not that it's completely impossible. You could also, whenever there is an attack or there is an big threat happening, it does become available on public sources. So on like Twitter, on vendor's website, on whichever vendor first detects the attack is always, they always want to be the first one to expose that to the world. So they always have it in their blogs and bulletin boards saying that, hey, we have detected this new attack, we have detected this new IDS, what do you say, alerts that are happening. But yeah, the red ones, I agree, they are a little difficult if you are totally going to do this by yourself. So yeah, that's what I have. So other than prioritizing vulnerabilities by exploit and exploit kits, you could also prioritize them by high-risk software. So by high-risk software, what I mean is these are the vulnerabilities in the past that had exploits or exploit kits available. So automatically, I mean, most of the Adobe Flash, it has been the top target for exploit kits for the last year or so. So yesterday again, not yesterday, Tuesday, yeah, yesterday was Tuesday. So Adobe also released 6 or 7 Flash vulnerability fixes yesterday. They were not used in the wild. There is no exploit for it right now. But intuitively, I know that in the last year, Flash has been targeted by attackers. And if there are 7 vulnerabilities fixed in Flash, I should fix Flash first. And the reason why I say that is once a vendor releases a patch, there is sort of a race. So between between the good guys and between the bad guys, and both of them do the same thing. So once a patch is released, what the bad guys do, and also what people like me do, is is we start disassembling the patch. So these patches are binary patches. So there are tools like IDA Pro or WinDiff, where you can see the difference between the patched binary and the unpatched binary. So and that's the same thing which the attackers do as well. They start diffing these patched and unpatched binaries, and the hope is that they are trying to find what was patched, because the description of the vulnerability just pretty much says what are the consequences. That okay, there is a buffer overflow vulnerability and it can cause attackers to take complete control of your system. That's it. That is the description. But what happens when a patch is released is that attackers start diffing your patched and unpatched binaries, and they're trying to find what was fixed. And once they find what was fixed, they see if there is an attack surface. Can this be attacked remotely? Or how can basically, in case of let's say Adobe, how can I create a malicious Flash content which when rendered in your browser would cause the browser to crash and execute my content that I gave it. So, and the reason good guys do it is or the IDS people, antivirus people, vulnerability management people, all these guys also use the same technique so that they can write signatures to detect the presence of this vulnerability. So, the reason why I'm saying that prioritize high risk software first is because if you sort of already know that Flash is something which is being exploited these days, even though there is no exploit for all the 7 vulnerabilities in Flash that were released yesterday, there is a high probability that someone would find how to exploit it and come up with an exploit. So this is just a distribution of vendors that had exploits associated with their vulnerabilities. Now again, if you look in here, if you look at it, if you would say, okay, Microsoft is number 1, Adobe is closely number 2, or they are almost the same, Apple, Oracle, and there are a lot of vendors after that. But again, if you take a closer look, what we saw was that although Microsoft was, number 1, it had very few remotely exploitable vulnerabilities. So on the left-hand side are the remotely exploitable vulnerabilities, and in Microsoft that was basically IE, Edge, and so on and so forth. But a lot of vulnerabilities for Microsoft in the last year were privilege elevation vulnerabilities. So something where an attacker already needs some credentials on the box, and using the vulnerability they can get higher privileged credentials. Now again, I'm not saying that's an unimportant vulnerability, but again, it's not a remotely exploitable vulnerability. So if you, in the same chart which is here, if you sort of dissect it, you see that Microsoft has less remotely exploitable vulnerabilities, but Adobe had a higher number of remotely exploitable vulnerabilities. So again, whenever you're looking at some chart, some numbers, some data, it's always good to sort of dig deep, because yeah, I mean, data can just be useful, but also can be misleading in some instances. Number 5 is prioritize unsupported or end-of-life software. Now, this is a really hard problem to solve, and that's because unsupported software, so let's say Windows XP or Windows 2013, it's something where the vendor, and again, I'm not picking up on a certain vendor, this happens with all vendors. When a software is, when a software goes out of support, the vendor stops issuing security patches for it, but you still have it in your organization. What happens is that when a new vulnerability comes in, so let's say Oracle released their quarterly patch update 2 weeks ago. When that happens, they say, okay, these are the patches, these are the operating systems or databases or software which is affected. And that is the list of supported software. Nothing is mentioned about unsupported software. So what attackers do is they take these exploits, and again, when I'm sort of generally referring to attackers, these are sort of mid-level attackers. These are not really the ninja attackers who really know how to infiltrate and all that. Just a normal person who had sort of gone on the dark side, what he would do is they would just download exploits from exploit DB, and it says that, oh, this exploit works for Windows 10. They can just run that exploit on Windows XP, an older operating system, and try it out. If it works, all of a sudden what you have is you have an exploit for an end-of-life system for which there is no patch. So organizations are really caught in a very are really in a bad place where if with end-of-life systems, because they have exploits which work on newer operating systems and there is no patch. And this happens, as you can guess, because a lot of code is reused. I mean, whenever there is a newer version of any software, code is not written like 100% from scratch. It's just an iteration. It's just a small iteration of the older software. So any vulnerability that affects newer software, chances are that 80% or more, it will also affect the older unsupported software. So the screenshot that I have here is what we have, and we sort of again provide for free, is that we run these exploits that work on newer operating system, newer exploits on older unsupported operating systems. And if they work, we say that, hey, this is an exploit, the vendor is not going to talk anything about it because the OS is unsupported. They don't even tell if the unsupported OS is vulnerable or not vulnerable, because it's unsupported, they don't talk about it. But what we find that this newer exploit does work against older unsupported OSs. So you can use resources like this to check what exploits work if you have any unsupported operating systems, databases, or any sort of a software in your organization. By the way, does anyone even care about this? Or do you know if you have unsupported operating systems in your organization? Is it a big deal? Or people just say that, oh, we have mitigated it because we have these other mitigation controls around it and we are just protecting it somehow. Any feedback around this? Mostly because of the business. Yeah, in most cases, it is the business case that an organization had some software, a custom software that only works on, let's say, Windows 2003, and now 2003 is unsupported, but that software does not work on, let's say, 2016. And so people end up keeping these older operating systems, older systems in their organization. It's a hard problem to solve, and yeah, I don't think anyone has like a very good answer for this. So again, these are some of the end-of-life software which have vulnerabilities, and as I showed you from the screenshot before. So just because you have an end-of-life software and the vendor doesn't tell you in security advisories that it is vulnerable, doesn't mean that it's not affected. I mean, you can run newer exploits against this end-of-life software, and you will see that yes, they are affected. Prioritize vulnerabilities with high lateral movement. Now, again, this chart is from, this graphic is from Trend, and what we did was that, and this is something that, again, up till now, what I said, I think you could do all these things by your own, more or less. This, I'm not sure how you could do it by your own, but what we did was that we, in the last year or so, when we analyze, like, as I said, like what we do on a day-to-day basis is when a vulnerability comes in every day, well, there are multiple vulnerabilities that come in every day. We analyze them, we throw them into buckets, we create signatures to detect them, and well, move on to the next day. So when we do this analysis process every day, we also tag vulnerabilities that have a high lateral movement potential with a special tag saying that, hey, I think this vulnerability has a high lateral movement potential. And we are trying to see how we can again expose this data to the community so that we can also somewhere post that, hey, these are the vulnerabilities from the last year or something which have a high lateral movement potential. So if you have them in your organization, patch them. Well, after you patch the vulnerabilities with exploits and with exploit kits and with active attacks and all the things that we saw. So, and these are some of the example vulnerabilities that, again, they may not have an exploit, they may not be exploited in the wild, they may not be for end-of-life software, but in our opinion, they have like a high lateral movement potential. So in summary, I mean, I'm sure in your risk management program, you must be using a lot of things like CVSS scores, the severity that is given by the software vendor. Let's say Microsoft gives some severity to their vulnerabilities, the severity that is given by your risk management program. But I think what we can do is we can use some of the pointers, like 3 or 4 or actually 5, 6 different things that we saw today here to put different severity levels so that you can prioritize remediation according to those severities. And by the way, everything is, I mean, it may feel all sad and gloomy because, you know, there are vulnerabilities every day, attacks every day. I'm always behind. It's a battle that you just can't win. And actually, that's not the case because so while we were working with, so Verizon came up with their data breach report, right? Like a few days before. So while we were working with Verizon on the data breach report, and we are also working with Cisco on their report, what we are seeing is that actually the defender behavior is having an impact on attacker patterns. So what I mean to say is that we saw that in so 2 years ago, in 2015, it used to take about 140 days on an average for an organization to fix 80% of their Adobe Flash issues. 140 days, so a pretty long time. In 2016, since, you know, Flash was rampantly used by exploit kits and exploits and attacks, people started, or organizations or people like you started applying flash patches more aggressively, and that time dropped to about 2 months, so about 60 days. And again, this is to patch 80% of flash in your organization. And that time is dropping faster and faster. What happened was that since, as I mentioned, like attackers have only that window. When a vulnerability comes out, they reverse the vulnerability, put the exploit in their exploit kit, and wait for unpatched machines to connect to them. Now, if organizations patch their resources quickly, what would happen is that yes, they will get visits, but then since the browser, the plugin is patched, the exploit just won't work. So what we have seen is that since, I mean, this could be one of them, not saying this is just the factor, but this would be one of a contributing factor for that we are seeing actually a reduced number of attacks this year for Adobe Flash and generally in exploit kits, is because we have seen that, I mean, we have data and we have seen that organizations are much more aggressively patching Flash. So I think what we are doing does make a difference, and like, as I mentioned, the defender behavior on how we prioritize vulnerabilities, how we fix vulnerabilities, that does have an effect on attacks. Now, of course, attackers will go to something else. They always go at the next low-hanging fruit. So if, let's say, Flash usage is going down and Flash patching is becoming more aggressive, they will definitely find a different software, something different to attack. So yes, it's sort of a never-ending story, but what I just want to say that this, how we behave, how the defenders behave, definitely have an impact on attacks and on attacker patterns. So that's all I have, and I would like to open up for questions. Mm-hmm. Okay, so the vulnerability rating, it does take that into consideration up to a certain extent. We can also it's too much of a vendor related question, like so I can chat. Yeah, no, it does, and we can chat about it after the presentation as well, but yeah, it does. All right, then if there are no more questions, then thank you.